Hey, good morning, Algebra 1. It's Mr. Mays coming at you. It's Monday, and I want to go over some stuff in Algebra 1, section 4.4 and 4.5. We're doing scatter plots and then how to fit that line of best fit. So here we go. All right, so 4.4 talks about using a line of fit to model data. Okay, so the whole idea here is if you're given a data set, that it doesn't always fall on a straight line. Doesn't always fall on a straight line. Okay, so we do something called a scatter plot. And here on page 196 of your text, they give a wonderful definition of a scatter plot. And if you will notice, the example they show there, that data does definitely not all sit on a line, nor does any of that data. But nonetheless, it still can be represented by a line, and we call that line a line of best fit. But before we can actually do the line, we have to be able to look at the data and decide what we have. So there's three ways that data can come out on an XY grid. We can have a correlation that is positive, as this case right here. Notice that there's a correlation. As the X increases, the Y is also increasing. So we say that's a positive correlation, and the line would fit generally in this area right here. And we'll talk about the criteria to set that line here in a minute. Now here's a negative correlation. Notice in this data set, as X gets bigger, Y gets smaller. Then that would be a negative correlation. So you could fit a line through here that could represent this data. Now this is a mess. Notice that this data here, there's no correlation here. You just have a random pattern. That signifies that there's no correlation between this independent variable. This independent variable X has no bearing on this dependent variable Y. So, identifying correlation. So if I look at example number 2, I can look at this data set right here, and I can say, well, kind of a mess. This one looks pretty good, though. Look at that. Okay? Nice. I can see something here. All right? So they look at the A part. The points show no pattern. So this is just kind of a mess. There's no way you could put a line through here that could represent this. I mean, I could start here and go this way. I could start here and go that way. There's all kinds of combinations I could do, but none of them really make sense. This one, yes, I like that. Okay? So when we do these, we look at our data set and we plot the data. Okay? And then we try to fit a line through this. Okay? So we have this core concept box here on page 198, and it is using a line of fit to model the data. Okay? So finding the line of fit. Okay? So you plot your points, and then we can look at our scatter plot, and we can decide whether the correlation is positive, negative, or none. And we can follow these steps here in example number 3. It says make a scatter plot of the data. Decide whether the data can be modeled by a line. Because the scatter plot shows a negative correlation, you can fit this data. If you were to graph that, you'd see this beautiful negative correlation. And then it says draw a line that appears to fit the data closely. Now this is the part that's subject to a little bit of interpretation. Now notice the data, the line they drew. They started here. They have a point above, 3 points below, a couple points above, 2 points right on the line. Okay? And they drew a line through here. So I have 3 points above the line. I have 3 points below the line. And notice that the vertical distance kind of cancel each other out, don't they? And then these 2 points being right on the line. Now they use these 2 points to actually find the equation of the line. And you know how to do that 3-step process, right? Use this data, find the slope, point slope, and then slope intercept. And that's exactly what they did here. They found the slope using those 2 points that they actually put on the line when they drew it, used point slope and to slope intercept. That's the gist of section 4.4. Okay? We've got some exercises in here. Notice we're going to do the average set. And I posted some notes on there for you. So that's what you get to do. And if you look at some of these, I mean, they're pretty obvious that, you know, you look at number 10. I mean, can you see a correlation in this data set here? It looks like somebody hit this with a shotgun. It's a mess. Now, number 12, you got a little blob up here on top, but then you kind of have this general downward trend. It's not a really good correlation, but it's, you know, it's a negative correlation. This one here, you could say, yep, that looks pretty positive. What about number 11? 11's a mess, okay? So you can kind of look at this. You can look at this data set here. I bet I could do something through here. Look at that. I bet I can find 2 points right on the line. I got about the same number of points above the line as I do below the line. I could put a line through there. What about that one? Yeah, it looks pretty good. I can do something here. Okay. And then you got a couple of data sets and you get to play around with that. All right, and then 4.5. Now that we know how to draw a line, we get to analyze the line and we see how good our line actually is. Now, in 4.5, we use something called a residual. Now, I know that this shows up on your MAPS testing, and the residual is simply looking at the line of best fit. In this case, there's our line. And then you look at the data point that corresponds. So here, if x is 1, your data point was 19. The model's value was 18. In other words, if you put a 1 in for x, you get negative 2 plus 20 is 18. The model says you should have got an 18. The data set, you got a 19, so that gives you a positive 1. Your data point minus the model is equal to 1. And then you do that for all of your points. And if you look at this, notice that you have a 1, negative 1, negative 1, negative 1, 0, 0, 1, and 1. You have the same number of ones above, positive, as you do below, negative. And then, of course, you have your 2 points, which came out perfect. Okay? So you add all that up, and you find you have a good fit. Okay? The minimum, your residuals turned out to be a very, very small number. So negative 1, negative 1, negative 1, negative 1, negative 3 plus 3 is 0. That came out perfect. They don't always come out perfect, by the way. Okay? So, here is another model. Now notice, when they plotted these points, if you look at this, you kind of have this U shape, don't you? Now, when you guys get into statistics, you're going to find that not all of these are linear. Some of them may be parabolic. Some of them may be a wave. Some of them may be exponential, something like this. But anyway, this one seems to fit a curve, and we're studying linear. This does not fit a linear pattern. Okay? All right, now here is finding the line of best fit using linear regression. So this is what I did. I have a little example of linear regression. So here's a data set. And if you will notice that most of my points, like for this point right here, remember it's this vertical distance here. The vertical distance here, notice they're about the same. This one here, they're about the same. And then all these points up here. So this is a pretty good fit. This is a pretty good fit, okay? So the equation of my line, I kind of guessed one through here. Okay, notice it didn't hit any points. It didn't hit any points, but I have about the same number above as I do below, and the vertical distances for those points are about the same. So that's not a bad line, not a bad line, okay? But how good is the line? Now, there's the formula to find R, okay? That's why they say to use a calculator. But the way this reads, it's the number of points times the sum of your x times y. So you take all your x, each point, take your x times your y, and you add all those up. And then you subtract the sum of the x's times the sum of the y's. Okay, and then you divide that by the square root of the number of points times the sum of your x squared. So you square all your x values and add them up. Then you subtract the sum of the x values squared. Notice the difference here. Here you squared all the x values and then you added them up. Here you added up all the x values and then you squared it. Okay, and then you do the same thing for the y's. And that will give you a number somewhere between -1 and positive 1. If it's a perfect correlation, you will get, and here's your little box down here, you will get a positive 1. Now what this says, if you get an R value of say 0.96, it says there's a 96% chance that the independent variable has the positive influence on the dependent variable. And if you have a negative, say 0.8, it says there's an 80% chance that the independent variable has a negative effect on the dependent variable. That's what that R value means. So if it's perfect, that says that the independent variable has a 100% effect on the dependent variable. And if it's a negative 1, the independent variable has a 100% negative effect, in other words, you're going to go downhill, on the dependent variable. That's what the R value means. Now, we are not going to calculate R values. As you can tell, it's kind of a mess, okay? But most of your scientific calculators have that equation built into it. So if you enter your data and tell it you want to calculate an R value, that's the calculation that it's going to perform on the data set that you put in. Okay, and then you guys get to do some correlation and causation. I'm not going to focus on this, but you can dedicate entire classes on correlation versus causation. Just be familiar with what it is. Okay, just be familiar with what it is. And then you get to do some exercise sets here. Okay, now I'll post this up on Google Classroom because I'm going to modify that assignment. You're not going to do all of that. All right, so that's what I got for you guys for section 4.4 and 4.5. And I'll get those posted up. And then when we come back on Monday, the 30th, we're going to do the sequences in 4.6. We're going to do arithmetic sequences. Okay, because these are kind of cool. So until then, let's get 4.4 and 4.5 finished. And I'll get the notes posted out there for you if they're not posted already. I'll get this posted out there for you, and we can get that wrapped up. Okay. Well, that's all I got for you for today. Hope you find this useful. And for those of you that did participate in the Google Meet today, thank you very much. I'll probably post another one of those tomorrow. And then if we stay in distance, which, boy, I hope we really don't, then we'll go to a Google Meet on our actual scheduled meeting days. All right. Well, happy Thanksgiving. If I don't talk to you until then, have a wonderful day. May's out.